Have you ever wondered how physics can pretty much predict the future? Well, today we're going to do just that. We're tackling a classic cliff problem. It's a kind of puzzle that's fundamental to understanding motion, and we're going to break it down step by step to show you exactly how it's done. So that's the big question, right? When something's falling, it's not just random chaos. Physics actually gives us the tools to map out its motion with some incredible accuracy. And today, we're going to open up that toolbox and see exactly how they work. All right, so here is our scenario. Picture this. You're standing on a really tall cliff. Someone takes a ball and throws it straight down. They're not just dropping it, they're giving it an initial push, a starting speed of 15 meters per second. This is a throw, not a drop, and that's a really important detail. Okay, so we have two missions today. First, we need to figure out exactly how fast that ball is moving after 8 seconds. And second, we've got to calculate how far down it has traveled in that same amount of time. Two separate questions, but we can solve them both using the same logical approach. Now, before we even think about touching an equation, the first step in solving any physics problem is to stop and take stock. What do we actually know for sure? So let's act like detectives and gather up all our clues. Okay, here's what we've got. Our initial velocity is negative 15 meters per second. The acceleration from gravity, which is a constant here on Earth, is negative 9.8 meters per second squared. And of course, the time is 8 seconds. Now, you're probably seeing those negative signs and wondering what's up. In physics, signs are everything. They tell us the direction. We've decided that down is the negative direction, which makes sense, right? So that means the initial downward throw is negative, and the downward pull of gravity is also negative. All right, with all our clues gathered and organized, we are ready to tackle part 1 of the problem. Let's zero in completely on finding the ball's speed right at that 8-second mark. To solve this, we need to pull the right tool from our physics toolbox. And for this job, it's the kinematic equation for final velocity. It's absolutely perfect because it connects everything we know, our starting speed, gravity, and time, with the one thing we want to find, that final velocity, which we call VF. And from here, it's actually pretty straightforward. We just take our known values and plug them right into the equation. So the initial velocity, VI, becomes negative 15. Gravity, G, is negative 9.8. And time, T, is 8. Once everything's in its place, all we have to do is the math. And boom, there's our answer. The final velocity is negative 93.4 meters per second. Remember, that negative sign just tells us it's moving downward, but the speed itself is 93.4 meters per second. And that is fast. We're talking over 200 miles per hour. It's a pretty powerful example of how quickly things speed up under constant acceleration. And just to hammer this home one more time, that negative sign is so important. It doesn't mean negative speed. That doesn't really make sense. It's all about direction. And in our problem, negative means down. Simple as that. All right, one question down, one to go. Let's jump into our second objective. Now we need to figure out how much ground, or air, the ball has actually covered. How far has it fallen from the top of that cliff? So, it's back to the toolbox, but this time we need a different tool. This is the kinematic equation for distance, or displacement. You'll see it written as delta y. That little triangle, delta, just means the change in. So it's the change in the vertical position. This formula is specifically designed to find out how far something goes when it's accelerating. And hey, you know the drill by now. The strategy is exactly the same. We substitute our known values into the formula. Now, check this out. See how the time is squared in this equation? That's a huge clue that the distance an object falls doesn't just add up steadily. It increases dramatically the longer it's in the air. So let's plug in the numbers. Negative 15 times 8 plus 1/2 of negative 9.8 times 8 squared. When you crunch all those numbers, you get negative 433.6 meters. So in just 8 seconds, that ball has plummeted more than 433 meters straight down. To put that into perspective, that's way taller than the Empire State Building. So there we have it. We found the final speed, and we found the distance. We solved the whole puzzle. But, the answers themselves aren't actually the most important thing here. The real takeaway, the thing you can use again and again, is the process we followed to get here. Think of this as a recipe that works for tons of physics problems. First, you identify your knowns. Just list out all the info you're given. Second, choose the right tool for the job, the equation that links what you have to what you need. Third,
Substitute those values in carefully. And fourth, and this is a big one, always understand what those plus and minus signs are telling you about direction. This methodical approach is your key to success.
And that brings me to one final thought to leave you with. We solved this whole problem for a ball that was thrown down. But what if you are on that same cliff and you threw the ball up with that same initial speed of 15 meters per second? Which one of our starting numbers would have to change? And how would that affect the final answers? The physics is all the same, so give it some thought. Thanks so much for breaking this down with me today.